Because I did record last week, so I haven't done anything with it. I probably should upload it to YouTube, or at least edit out the end and beginning and end.
You have access to YouTube?
I don't know. I don't think I do.
Okay. Yeah, I will talk to you later.
It works for me. Oh. Mm, yeah, so we looked at the light shafts, and I remember us talking about, were these the IP the standard for the shape of the light bulbs? Or is that a
Oh,
different thing?
IEC, something, something.
Yeah, IEC stuff. I think, yeah, we were looking at the videos of these, and it's just like they built up the flares from a whole bunch of things. Lens flare constants. Okay, yeah. Plus TAA and FXAA.
I had some adventures in TAA this week. I guess end of last week.
Ooh.
Rendering something at like 1/16th the screen resolution, and you literally can't tell because of the reprojection and stuff.
Wow. Is there like a single good resource for learning how to do TAA? Because it seems kind of nebulous from what I've seen.
There's something in the what is it, the channel we've got for meeting topic suggestions. I haven't looked
Okay.
at it, but I think that might be a good one to look through for a meeting.
Oh yeah, here I got it. Oh, nice.
So what's interesting here is they have TAA and FXAA at the same time. Ooh, yeah.
Is FXAA the one where you do stuff with like the edges and
You need the depth, because this is what that says, but I'm not that familiar.
so like where you get more samples along the edges or something?
Fast approximate anti-aliasing. Hi, Wikipedia thingy. Input data is rendered image and luminescence. Okay. So it requires the luminescence data. Find high contrast pixels by using a high pass filter on the luminance data. Low contrast pixels are excluded from being further altered. A high pass filter that excludes low contrast pixels can be tuned. Use contrast between. So we find edges. Determine whether the edges are horizontal or vertical directions. The blend direction of a pixel will be perpendicular to the detected edge direction of the pixel. That makes sense. You blend along the edge, not across it. Calculate one blend factor for a high contrast about analyzing the unit in a 3 by greater pixels with the pixel in question being the center pixel. Search along the detected edge to determine how long the edge goes on for and what direction the actual edge goes when the detected horizontal or vertical edge.
Honestly, TAA is a lot simpler than FXA.
It sure sounds like it. Yeah. Makes sense though, if you're just blending along the edges just to avoid screwing up the contrast. That makes sense.
I was with them until step 6 there.
Yeah.
Yeah, I'm not exactly sure because that starts getting a little less local, seeing how long the edge extends.
Yeah,
It's approximate. So let's see what it says about it's cheap. That's nice.
Right, so you're only actually doing AA on the stuff that looks bad.
That is one nice thing. It's not MSAA is geometry based, which doesn't help if you have, alpha blend textures and just other things that are aliasy. High contrast texture maps blurred before HUD and seems like, yeah, well, it was developed in 2009 and it works for a world in a 2009 graphic stack more than
Wouldn't it be simple to use like an outline shader, and then wherever there's the outline, you just blur that, and it should work like anti-aliasing.
that sounds like what it does. That's very similar to that's how it sounds like. It uses contrast to determine contrast. It figures out where the edges are, like an outline shader would, and then blurs around the edge.
It
Or along
doesn't.
the edge.
It'll blur in the wrong direction if you use an outline shader. Because if you have, well, it's really hard to describe, but basically if you have a vertical pull, it'll blur horizontally when you want a vertical blur.
Actual code for FX.
Again, hard to describe. I can link a tutorial.
Oh.
So this seems, I feel like TAA is easier to understand conceptually, but more complicated to actually implement because there's a lot of details to get right. Because there's this ghosting thing because you're not it's using previous frames and it's not reprojecting. Disocclusion. So you have to do more tuning. Well, that's an interesting demo. Oh, it's a video. So you can reject stuff with depth, stencil, velocity.
Honestly,
Yeah.
honestly, you just need neighbor clumping, and it should work pretty well.
Oh, you got this shimmer. Oh, I didn't want to do that. Where's the oh. I'm just going through this. I'm flicking through this tutorial. I'm not really getting heavy into it. If that wasn't obvious. That makes a lot of sense. Like, why it would be blurry. That is a sharper image on the right.
Yeah, that algorithm is called Mitchell-Netravali, I think, and you can approximate any type of curve using it.
Wait, are you talking about this
Yeah.
thingy here?
Yeah.
That's
Like you can approximate any curve that you want using the BNC.
ah,
Wow.
that's
Mitchell-Netravali.
that's
Huh. Yeah, that's cool.
so when you say approximate a curve, you're referring to
Catmull row or biliteral.
yeah, the filters and other things.
Yeah, yeah. And the blue one at the bottom is my approximation of it.
Oh, okay. Just that does look to be a bit cheaper than this. I mean, just
Yeah, but it's less accurate. Like if you take the integral of the Mitchell-Netravali curve, it's always going to be 1. With mine, it's like 0.99 or something like that.
well, it wouldn't be called an approximation if it worked. Well,
But,
in every situation.
yeah.
Oh, that's so. What you just said is that the integral of this is always 1. Oh
Yes.
yeah, because I can see you got the triangle here, and that's half a square, and then the bit over here you subtract away. So that's
Yeah, you wanted it for it to be 1 because that way the image stays the same.
right. Right. I hadn't considered that, but that makes a lot of sense. Because I was wondering why this was like bounded to such what I felt like a small range of things. Yeah. It's like over here we have, oh crap. This one, yeah,
Oh, lol.
this one has a bigger range on it, so I was confused by that as well. 2 lobes if you go beyond 1.
Yeah, it starts to break.
Yeah.
I wonder if the thing about the integral still holds.
Oh yeah.
Probably. I mean, just looking at it, it dips down further the higher up you go. Similar there. That's just my guess, not any fact.
I wonder how that will look in practice.
Great. Interesting though. Yeah. It definitely. Can I zoom in a bit? Yeah. I don't know if you guys can tell, but that is significantly clearer over here than this is much blurrier. So it seems using a Catmull ROM filter could be done better. Or does a better job because of what's being described up here, which is the blurring due to sampling artifacts, if you will. Sharpening pass. Just the texture blurring aspect.
Hey, how do I get to this page?
It's really. If someone just said something, you were really quiet.
How do I get to this page?
It's so in the general in the general voice channel, if you hover over the title general, there should be a little chat thing. That's how you open up the chat for the call. It's like attached to the voice channel. I'm assuming that's what you were asking. Because once you get there, all the links are there. You just have to scroll up, or well, JB just posted it
yeah.
again, so you know it's right there. So unjitter.
Mm.
That's interesting.
Just magnitude. Huh. Yeah. This is almost an outline shader, or an outline type of thing.
Yeah. But when I was talking about the outline shader, I meant the one where you expand the vertices towards the normal, and that's what you draw, like behind the main shape.
Right. That makes more sense. For whatever reason, I was thinking of the article, "The Quest for Ridiculously Wide Outlines," and they ended up using SDFs. I thought it was.
Huh, really?
Quest for big outlines. Very wide. It's jump flood algorithm is what the ultimate solutions had seem to be. Mesh-based outline is cheap, but it does have some artifacts and or issues and situations.
It works if you smooth the normals.
Well, I'm not disagreeing with you, but I will say the jump flood algorithm allows for some very sick things to happen because it's basically an SDF. So if we scroll down further, we get to some very wide outlines, and it shows the relative, I think, performance between them, and it shows that the jump flood's really good, but I guess it doesn't compare the mesh outline here. But then they get into, wait a second, we can do more than that. And if I scroll down far enough, because this is a really long article, we'll find it. And it's taking a while. Yeah. This is what I mean by being able to do more than just an outline, a shader, a mesh thing could.
There should be in Psychonauts.
Yeah.
Yeah, it's basically calculating the distance from the edge.
There's a whole ass shader for it. Scroll, scroll, scroll.
Jesus Christ.
It's like the whole thing, as far as I can tell. Is this? That's the. Oh, this is like the game code too. This is not just the shader. I think, yeah, because you got create command buffer for their the Unity stuff that I don't actually quite understand. That's why it's at the end. But yeah, that's just what I was thinking of, rather than a mesh-based outline, which yeah makes more sense in the context of the conversation. Yeah, your keyboard's really loud, JB.
Oh shit, sorry. Yeah, it's actually the funny thing is my boss actually works on this shader. But if you like scroll down, you can see like a mesh-based outline.
It's the yeah. Okay, so if you want to do an outline, this is a good reference for it. This is what I'm hearing. Let's see.
Well, it's a lot easier than the one that like over this is just extruding the vertices and then coloring them some color. And there's a special script for smoothing the normals, because otherwise you're gonna have discontinued outlines.
There's a vertex extrusion and
Yeah, like
see what this.
to find it, you need to type it in GitHub.
Uh, Found it faster than I could. S- Oh. Oh, is that what you mean by smoothing the normals?
Yes, yeah.
Oh, that makes all the sense, because when you have a cube, this is a very good description, because when you have a cube and you want each face to have the correct normal, you have to have 3 normals per corner. But
Yeah.
if you try to extrude, you're gonna get the mesh.
Discontinued.
Yeah, because it's gonna go sideways, but not in the corner direction of the corners when you extrude it. It's like it only explodes it along the axes, the 3 coordinate axes, instead of, well, an actual scaling.
Yeah, yeah.
Okay.
So I was wondering if you can like render to a texture like this mesh outline. Would you be able to do anti-aliasing that way?
I don't know. Do you mean for everything in the scene?
Well, if you have like a bunch of outlines, that's kind of like saying the edges are here, so just blur them.
Oh.
But they're going to be offset from the object, right?
Well, with the smoothing of the normals, they're gonna be right around the object.
But they're going to be like around the edge of the object rather than like on the edge rather than like actually the edge, right?
They're extruding from the edge.
What about self-shadowing, where you have like the arm in front of the body, but the arm and the body are separated? There's a distance between, like, the arm is extended forward, but the arm is in front of the body, therefore it's not going to have an outline around the hand. It's
Yeah, fair enough.
so
It is a bit limited.
it's an interesting idea nonetheless.
I guess that also requires that you are making outlines on everything in the scene. Because otherwise, if you're not, then you have to do the
True,
line
True, but
stuff.
mesh outline is relatively cheap to do.
But if you already have to do the edge algorithm for everything else in the scene, it's kind of just extra work. Right?
Yeah, but I was kind of proposing it just doing the mesh outline and then blurring the edges there, like without other anti-aliasing.
Oh, so you only do anti-aliasing for the objects that have the mesh outline.
Yeah, yeah.
Interesting. I'd be curious to see if that would work.
I mean, maybe.
I think like I feel like it would be hard for it to be more efficient though, because like this edge outline in the FXAA stuff it's really just like subtracting a couple numbers. It's just getting the like derivative.
Yeah, but I still think it's TA simpler. Like,
Yeah, but sounds right.
So I did not realize FXAA needed luminance data. That would explain some of these images we've seen for like this. Well, that's a depth buffer. What am I thinking?
You can get to luminance just by reading the color, though.
Yeah, that's too.
And there's a common so-called optimization where they just read the green channel and calculate the luminance based on that. But it's not really an optimization, and it just makes the quality worse. So
Yeah.
don't do it if you're implementing FXA.
Or if you just. Yeah.
I
If
guess
you're
if you have like a
OS
planar texture or something, it might work.
Yeah.
when you're calculating luminance, why is the red channel's like contribution so little?
I think that has to do with like human vision kind of stuff, like your relative sensitivity to different wavelengths.
Yeah.
So that means we don't see red colors that well.
So if you have a red pixel that is at 0.5 brightness and a green pixel that's at 0.5 brightness, the green pixel will appear considerably brighter than the red pixel. And blue is also weighted a lot less than red and green.
All right.
So like my understanding, we have, you got your cones and rods. Okay, except all cookies. Show it. You have, this is a basic construction of your eye, but the detectors are at the back of the eye. There's different kinds of detectors. There's cones that are color sensing, and then there's rods that are black and white sensing. So at night, when you're, going through the house with only a night light, then the cone cells that are basically getting nothing because they're not sensitive enough. But the rod cells are, except they don't really get color anyways. There's more to it than that. However, the sensitivity of the cone cells, there's different types of cone cells, and I think this is a graph of it. There's like the yellow one here, but you can see that the green has the most area of all of
Right.
them.
Yeah.
And yeah, it is relatively well stated that human vision is. Now it's talking about color blindness, which is nice, but not what I was here for. Human visual acuity is strongest in the green area, green bands.
Okay.
Physiology, yeah.
Better to see in the forest.
Yeah. Yeah, but human perception of light and color is much more than just RGB. It just happens that RGB maps relatively easily to it. Yeah, we got
The note on the last sentence is jargon. Interesting.
the material near this tag may be using jargon that limits the article's accessibility. Okay. That's one of the yeah, so like we have different cone sizes and they respond to different wavelengths, and the large ones respond most to red and the small ones respond most to blue and the medium ones for green. Except light isn't a single wavelength. Color isn't a single wavelength. So yeah. Okay, I don't need to see that. Yeah.
Right. Yeah, I was like a while ago. I was doing like conversion, like from RGB to spectrum, like for a spectral renderer.
Mm-hmm.
Wouldn't it be cool if each pixel could hold a histogram or something?
I think they do that for some more serious ray tracing stuff.
Where's I didn't hear I didn't hear histogram. I heard Instagram, and I'm like,
Oh
what?
shit! Same.
Every pixel is this little square image? Wait, that's
They're
not what
not
he said.
squares.
Spectral. Yeah, this is where I remember reading or learning a good bit about spectral rendering. Where's the chat? There's the chat.
I
Oh
think
shit!
Kate. Do you guys know Kate? I see that she's in here. She was working on one a couple months back.
Oh,
Not in the room, but she's in the server.
Oh yeah, I've spoken with her before. Yeah, it's not perfect, but
I mean, like, we got the green. We want the yellow. We want purple. We want, yeah, I mean, it is a mapping. I'll give you that. Those are
I saw it somewhere and then I just recreated it in Desmos, but
these down here. So that's just okay. Those are those things.
What is this from exactly? What is this supposed to be modeling?
So if I'm gonna summarize because I didn't write this. I assume you wrote it, but
yeah,
like
I did.
light is not RGB. It's a spectrum of many things. And sometimes there's like colors of light that just can't be represented in RGB without, well, losing accuracy in physical accuracy. To our human eye, it might look mostly right, but it isn't the same thing. What this is doing is taking an RGB signal and turning it into a continuous spectrum of wavelengths.
The only thing that bothers me though is that it goes off forever to the right and left.
Yeah,
Well,
but it doesn't matter. Like
I'll zoom in so it bounds to our human visual cue. Yeah, there we go.
Well,
The
yeah, like
visible light spectrum.
the reason you need the spectrum is because whenever the ray hits an object, that object has RGB values like from a texture, and you need to convert that to a spectrum so that you can see how much weight the wavelength is gonna have when it hits the object. Yeah, and this not the best, but it does kind of work. I tried it.
It represents what you're thinking about or you're trying to do. Represents. It demonstrates.
It's a model.
Yeah, I guess.
I kept hearing about modeling, like not but my uncle is a retired petroleum engineer and has talked about modeling functions and systems and whatevers. And my computer science course never talked about that aspect of, well, engineering because it isn't petroleum engineering. But I feel like I would have appreciated that class because all this PBR and advanced rendering techniques seems to be doing a bit of that, where we're trying to model the real world using code and having like I don't say formal under a formal class on. I don't mean formal. I just mean a class on developing mathematical models would be useful.
Yeah.
That sounds useful.
And doing like applied math stuff, like because my
But it's
degree
also what I remember from being
like electrical engineering is an example of that. Like you kind of see it in like electrical circuits and like how you
Yeah.
calculate values of it.
Okay. Yeah.
You know, I'm pretty sure that I was actually close to making a proper RGB to spectrum.
Not enough pictures, too much code.
Fuck, I can't
This
find
is
the.
this is to other things.
I think PBRT would be a good thing to come back to. I think if we did it in small chunks, I think we could. I don't know.
We were waiting, hoping the V4 would come out.
It's only been a couple years.
There's like an actual date now, right?
Is there?
I feel like I remember seeing something recently about.
Let's see.
Last update 9 days ago.
Right, mid-February.
Are the different editions different enough that it's worth rereading?
Sounds like this one was going to be quite different with a lot of GPU-based stuff, right?
As a group, we haven't gone through the PBRT book.
It's a big
Like it,
It would be a lot of effort.
right. But we were hoping that V4 would come out and then we could do parts of it, or at least, and then not feel like we need to rehash old stuff, though. We've been talking about maybe doing some of the things we've done before again because it's been long enough and people have learned more and can do a better job.
Are you guys talking about a custom path tracer?
I mean, I'm not, but others are.
I mean, I can do next event estimation and multiple importance sampling.
Yeah. The important sampling stuff is something I'm interested in learning more about.
It's really simple, honestly.
Cool. Okay.
I can try to explain it now if you want, but I don't know.
I do want to try to make it through some of the things in the article here, at least.
Yeah, maybe we should have like a dedicated time for that sometime. That'd be cool.
Yeah, I'd be down. Very down.
Sure.
Does it talk about TAA? Did I skip it? No, it doesn't really talk about how it works. It just says it does it, and then
Yeah.
shows like the velocity buffer.
So their lens flares are.
So this is no anti-aliasing, and I really need to zoom in to see anything. is this? This
Oh.
is like I can see some differences on some of the edges, but they're so slight. I don't want to look at too much. Ooh.
I found the resource I used to make the RGB to spectrum.
Yeah. This peaking here is a bit obnoxious, but
Sure.
I find the unlimited that it goes off to the left and right permanent, without coming back down, to be obnoxious. But yeah,
Well, I mean, the wavelength is going to be from 400 and something to 700.
Yeah,
But
so
you can see my curve is similar, right?
Yeah.
yeah.
But I don't know. I would have preferred like color. Sorry, go ahead.
You just assume all the objects in your scene give off a lot of UV light stuff.
Some of these are words I don't have any reference for. That's a lot of my reading these articles with all y'all. It's like, what does this mean? And then we find out. It's- So what is? I just want to know what this means. Oh.
I guess it's a song.
Yeah. Graphics program. Let's see if that gives us anything. Illness.
You're gonna need to put it in quotes.
Yeah.
You sure you didn't mean Lisp graphics programming?
This is looking promising. Iterative least log slope squared. Okay, so it does describe it. That's just an image. Oh, it's a shader code, or the code. Oh, yeah, MATLAB. Yes. I'm distracted. I'm just totally and utterly distracted. Oh, there's what? This is it? It's gonna take a minute to load. Oh, that's on the same website. Scott Burns. Oh, there's multiple pages. Oh. Okay.
If anyone, I'm curious if anybody's like an expert in color theory. Like, why not just model it with like 3 skewed Gaussians? That looks like when you see the actual color curves of RGB, it kind of looks like a skewed Gaussian.
Well, I think that's what I did in my Desmos link.
Oh, interesting. Okay. Yeah, but I'm curious why there's so many complicated ones. It looks like it's just a skewed Gaussian. Yeah. like all these different methods that seem more complicated?
Because if you look at it, the top part is actually more flat, somewhat.
Okay.
This is
But yeah, you can approximate using Gaussian curves, like.
Also, what is the relationship between color spaces and these types of curves? Like some color spaces seem to be like useful for like logically separating things, like luminance and whatever.
Contrast, stuff
Exactly.
like that.
I guess
And
it's like
some
if
of them
this is
seem to be about keeping things as linear as possible.
There is a color space that people use to do spectral rendering. The XYZ, I think, is the one they're using.
Okay, I guess that makes sense. I guess that's like the easiest to convert back into a histogram.
Yeah, it's a lot easier to convert back to color. I know that professionals use the CXYZ color space for spectral rendering.
Is the color space itself like linear? Meaning like, I guess not. It wouldn't be.
Different meanings of linear. There's linear in perceptual space, and then there's linear in actual physical space.
Yeah, I
And
mean like linear in eye space, right? Like so two colors that are a certain distance from each other should look different to the eye.
yeah, so one of the benefits of using different color spaces is that you can get perceptually linear color blending. Whereas
Yeah,
if you take physical color and try blending,
yeah.
you'll get
Okay. Yeah, I'm trying to
much.
figure out like, okay, so there's different color spaces that have these different advantages. So like if you wanted perceptually linear, you'd move to like one color space, and if you wanted like physically linear, then you'd move to like XYZ? Or am I misunderstanding?
I'll link a
No,
shader, Troy.
each color space represents different things. So the XYZ one represents wavelength and brightness and something else. I forgot what.
I'm seeing Y is lumen. Well, for the CIE, Y XYZ, Y is illuminant, Z is quasi equal to blue, and X is the mix of the three RGB curves. Chosen to
Oh
be
wow,
non-negative.
so weird. Okay.
I guess the simple way to look at it is just like you have the spectral values, which are the real colors, and then if you want to represent it with three values, you got to basically draw lines through there that those values will be a part of. So it's how you choose those lines is your color space, right?
Oh yeah, and don't mind the title.
Linear to non-linear. Wait, oh, float versus vec3. Okay, yeah. Non-linear to linear. I'm gonna have to.
You don't need to mind the exact implementation. Well, at least I don't. I literally just copied it. But down in the main image is where the interesting stuff happens, where you do all the conversions between color spaces.
It is just defining the left, the blue and yellow. And then, okay, so linear to sRGB to OCLAB. Okay. We take the non-linear to linear sRGB, so it goes from. Is it L? Oh, L is just the.
The left, which is blue.
Oh, so when you say non-linear, you mean perceptually linear, perceptually non-linear, but mathematically linear? because it's like a perfect, you know.
Okay, so the color starts out as sRGB, and that's what output is eventually going to be. Because Shader Toy doesn't do linear to sRGB conversion for us, so it assumes that we're outputting sRGB color, non-linear sRGB. And by non-linear sRGB, I always mean physically non-linear, but perceptually linear.
Okay.
I also shared a shader, my implementation of Pritam Sky, where they use the XYY color space, and then I convert that to XYZ, and then I convert that to RGB. Yeah, you need to like click and move the mouse up or something like that.
Oh. Stop. Like, can I get the sky to stop moving around? Oh. Oh, that works? Oh, that's so nice. Okay. Okay, we got the bright sun, you got a nice halo. How are you?
What?
I'm gonna put it to full screen. How did the how are you getting the lens flare? There's we go.
I think he linked that earlier.
Oh.
He linked an article on his blog.
Yeah, it's a really nice looking color too.
Yeah, thank you. Yeah, I was just experimenting one day with lens flares, and this is the result.
Yeah, hexagons come from the aperture, actually. So that's interesting to try and model that. For my camera, physical blades on the aperture.
But yeah, if you go to the Pritam Sky code, you scroll up to, you can see the conversion from XYY to XYZ and to RGB. Yeah, scroll down a bit, like to the bottom of the Pritam Sky function.
Oh, okay.
Yeah.
I saw it. Supreme Sky. Okay, yeah.
Oh yeah.
I wanted to make a comment about the lack of formatting in your code, and then I remembered I don't format my code. I let a tool do it for me. You're working in Shader Toy. Why would you bother spending like half an hour formatting everything manually?
Thank you. Yeah.
Just let the damn shader do it. Just let some tool do it.
Yeah.
At which I'm more annoyed at Shader Toy than anything. Oh, I see the XYY stuff. Yeah.
I've been looking at some of my old code from like a year or so ago before I started working at it, and holy shit, it was bad. Just having a set of coding conventions to follow that you like are relatively strict, like that just I don't know, just makes it so much nicer to work with.
Yeah.
Yes.
It's kind of, I don't care what your coding standard is as long as there is one. Because if it's all consistent, then you can just learn what is and isn't consistent, and it becomes much easier to navigate and follow and look through things because you're not having to deal with like, it's like a speaking in different accents in like natural language. It's like, imagine listening to the news where one person was from New York, one person was from the deep south, another person was a Minnesotan. I guess if you're not American, those don't mean much to you. But imagine all your regional, local accents just everyone has a different one, and it'd be such a weird experience to hear them back to back. Oh, that's what I imagine inconsistent code to be like. Yeah.
It's like reading someone's code when they mix tabs and spaces, but on their machine they didn't know the difference.
You can use yeah, it's very good color gradient. Oh, and oh, is that a so we have the main halo, and then as we go around, there's a oh, come on. There's a bit of a ring here. I don't know if you guys can see it. Can I make it? Yeah. I don't know if it can come across the oh yeah. If I could like adjust the contrast, I think it would pop, but oh yeah, there. Can you see the diagonal line going this direction?
I don't see shit.
Okay. I
Oh yeah.
Oh yeah, I can see it now.
and it's more visible when you're moving. I think that's because of banding. Yeah, I'm seeing banding along here. And I'm not sure why.
Throw some noise at it.
It might be my monitor more than anything.
No, I can see banding too, but that could also be due to Discord compression.
No, well, if I'm seeing banding and you're seeing banding, it's probably not the compression, but
Maybe it's the lens flare.
it might be. I mean, I just I could imagine that happening in a real camera though, with the way light works. Oh.
If it's not too complicated, I noticed at the top of your article you say if you have a bunch of 2D SDFs, you can then plug them into the e to the negative of the SDF. What is there any like what's going on there? Guess why does that help?
The larger the distance from the SDF is, the darker the color will be. So it adds like a halo that you can control, right, with the SDFs. So you do XP minus the SDF times the number, and the bigger the number is, the more sharp it will be, and the lesser the number is, the more gradient fall off it will have. So it allows you to control these things.
Okay, cool. That makes sense.
Yeah, pretty much.
Oh yeah. I've not used Desmos enough. How do you add variables? What?
Just k is equal to something. No. Below that, like.
Okay.
You should probably make that a k rather than an x.
Well, you know, I appreciate. There we go. I'm learning. Okay, so the stronger, the more the fall off is.
No, the larger the number, the less fall off there is, and the sharper it seems.
I don't follow, but I must be missing something.
Right. Like you know why it's going towards 0, right? When a number is to the power of a negative number, okay, so when a number is to the power of 2, it's x times x. Power of 1 is just x. 0 is x divided by x. And then -1 is x divided by x divided by x. And it continues going.
I guess I get a negative exponent is it's this graph. What I'm really asking is how does that apply to here?
Well, you can see like where towards the sun you have like a smoother halo, right, as it's going outwards. But then on the other shapes, like the torus shape, it's much more sharp because I multiplied the SDF by a large number, so it goes quickly from 1 to 0.
Okay. What did you link here?
Oh, that's just a
Oh,
random thing I made.
I'm sorry.
Oh, also look who commented on that.
I was just noticing that. I love how
Nice. Trick replace. Oh, that is. Okay, that's a little slow.
Okay, I have actually something interesting to share though. In Shader Toy that's not a shitpost.
Oh, is this supposed to be a shit post? Because
Yeah.
I feel baited.
I just wanted to see what it looks like if you visually merge yellow and blue.
I mean, I want to see it now too. I just don't want my eyes to be mangled while doing it because it's moving too fast. Oh, ow,
Oh,
ow.
Discord does not like that.
no,
My-
not at all.
Pink. I'm seeing pink almost.
So you can create a impossible
Oh,
color by looking at
oh,
yellow and blue.
Yeah, it does not feel nice to look at.
no. You know,
It's supposed to be soothing.
oh, uh, that is not working.
I think you need to
My
divide
eyes are bleeding.
iRoss.x.
Divide it by X?
I think you need to divide it by iResolution.x.
Yeah. What?
Spelled wrong.
That, I can't spell C, T, and S. I always confuse those because I took Spanish immersion in elementary school where T, C's, and S's, like the same sounding words use different letters. Okay, here we go. Wait. I can't get it far enough over.
Yeah, I just multiply it by like 5.
I think I should give up. Okay.
Okay, so this is related to dithering to get rid of banding artifacts.
Oh, nice.
And
What's the second row?
yes. So the
What?
second row is if you just add noise and 0 to 1 to your signal. And you can see that in the middle of each solid color, it sort of converges and they're like little noise. Yeah, there's
Yeah,
like areas of low noise.
it's like there's bands of solid color in between each of these things here. I don't.
Yeah, and basically the solution is to double the noise you add to it. I
This
have
is
an interesting presentation I can link that
This is
discusses this.
actually cool.
what's really weird is are these the bottom two solid color blocks? Solid blocks of
Oh
color.
yeah, you're probably seeing optical illusion where it
I
looks like
am. They're a gradient. It feels like
gradients.
this is a gradient across each block.
Yeah,
Can
but
you
if you
link that
use a
presentation?
magnifier, you'll see that they're solid color.
Can you link that presentation?
Oh yeah, it's in the. I just linked it in the voice general chat.
Why did you tell me to open the magnifier? I can't see anything now. Oh, here it is. No.
Well, maybe not the Windows magnifier. I use ShareX and I have a built-in magnifier. The Windows magnifier does some weird like
Yes, it does.
filtering on the image, and it doesn't. Yeah.
Having a different resolution monitors doesn't help too, because it moves it across both monitors, but it pretends it's like one giant monitor. That did not work. Okay. Oh,
Okay,
whoa.
this is an extension of the idea with the lens flare. Just this time I'm using fractals and some coloring tricks.
Yeah, I like this.
Oh. I just want to slow it down a
And
little
you should
bit.
go to buffer A.
Say what?
You need to go to buffer A for the actual calculations.
I use it a lot of places. It's not just one. My GPU is really, really not appreciating this.
Yeah, it's the SDFs are killing it.
Yeah, 100% usage.
And I'm doing like 15 iterations of it, so.
No wonder it looks so good, and no wonder it doesn't run when I full screen it.
Well, you can lower the iterations, like in the for loop, make it like 5 or something.
Oh, that's rock solid 60. Oh, that's beautiful.
I'm surprised I'm getting solid 144 frames with the standard one.
What GPU do you have?
2080.
That's okay. I have a 980.
Oh, okay, yeah.
Well, I have a GTX 970.
Yeah, you don't need a high-end GPU to do graphics development.
True, but I
But you
would
can
like
tell
to do
yourself
some
you do,
ray
so it
tracing
makes
stuff.
sense. I'll totally be using RTX stuff soon.
General purpose vector supercomputer since like 2014. They've gotten up quite a bit faster.
Oh yeah.
I think like the average GPU now is faster than like the fastest supercomputer in the world in terms of floating point calculations.
Yeah.
Than like the fastest one in the world in 2005 or something, or even later than that, I think.
Wow.
Is this the... Yeah, here's the image. Thanks. So, in 2000, the top supercomputer could do like 4 or 5 teraflops. Right? Gigaflops? What?
Logarithmic gigaflops.
So is that this should be 1 tera. I'm sorry. This is written with period, not comma for
Yeah.
so that's 1,000. Okay, yeah. Sorry. So this is 1.523 teraflops. I mean, the current supercomputer is in the exaflop range, I think. Or it's not exaflop, but it's close to it. Because this only goes to, well, teraflop, petaflop, exaflop,
If you go back to
right?
the image results, there was one thing I noticed. It's like a kind of interesting. Yeah, if you go back one more, I think. Maybe it was. I think this is.
Yeah.
That purple one in the middle row. That one. So it's visualizing relative scale of teraflops.
Oh yeah, that's I was reading the fine print and okay. So Fugaku. Weather simulations and innovative drug discovery.
Literally simulating atoms.
So yeah, the Sunway Taihu Light. When I was doing my high performance computing class, this was the fastest supercomputer at the time. Or was it Sierra? It was like it was neck and neck. Like look at that 125. Yeah.
Rounding error, yeah. I heard something, and I don't know how accurate this is. Somebody at work said that when they do these LinPack, things, I think that's what they call the benchmark. They do it as it's effectively doubled versus the actual performance of the thing because they consider a add and what is it, multiply and accumulate as a single instruction. Like the hardware considers that a single instruction, but then that's two floating point operations technically. So there's maybe a fudge factor there.
By the way, JB is doing some really cool shit on Veraldo.
I can share that later. Yeah, we run out of stuff here. Yeah, making some real strides on that. I started a new rewrite and it's much better than last time.
Nice. That's cool.
Share your screen. We're kind of just meandering anyhow. What's fun is that all the top 500 supercomputers run Linux. Like, let me just share my screen because I'm looking at it right now. For a little while there was some non-Unix based stuff, but since 2015 it's just all Linux.
Pretty cool.
No, none runs Windows.
I see a little smidge of light blue at the top of that.
Yeah, but it ends in.
Oh no, yeah.
I mean, it's on its way out. It's just
Like a little brief Mac install.
I wonder if some of those were render farms. Mac made good desktop and maybe even some server stuff back in the 2005 era. The other thing is in a supercomputer, the operating system is actually like the thing you want to be doing the least because you don't want to be doing operating system stuff all the time. You want to be like, computing.
Yeah, I wonder if you almost want like a real-time OS at some point.
No, because real time is a real time OS makes guarantees about the things going on for external clients. Like you need real time if you're doing flight controls, real time.
But
You
you'd
know,
probably want like really predictable like scheduling, right? Of your threads.
I don't.
Maybe not.
Does anybody use CubeOS?
What is that?
It is literally the world's most secure operating system.
Hmm.
It's what Snowden uses right now.
A reasonably secure operating system.
I appreciate their honesty. I guess to read the documentation. And I've been thinking about security for work-related stuff, and I'm just like, this is way more confusing than I ever want to be thinking about these things. Zen-based virtualization? Is that a... Now we're just... Is it like a custom hypervisor?
Oh yeah, is this
Yeah,
like
Zen's a
everything runs?
hypervisor.
Hmm. Because it's like everything runs in its own VM, basically, right?
Yeah,
Yeah.
pretty much.
But it's like it's the cool VM stuff, right? Where like the windows still look like windows you can drag around, but each window is in its own VM.
It's
So it doesn't
crazy.
seem like you're using a VM.
Yeah, it's secure-ish. I mean,
As secure as they can be in a world where Spectre exists.
yeah, pretty much.
I mean, they actually probably could make it reasonably secure because they like flush out the caches between each context switch or something. I don't know.
Hmm.
Or just disable but all the things that cause Spectre and Meltdown to be a possible attack vector. Okay.
So yeah.
Yeah. So I just quick math. 50. So if you wanted to build this Fugaku supercomputer out of GTX 3090s, you'd need 15,000 of them.
I mean, with cloud stuff like AWS, that's like not out of question, right?
What?
Like
Any-
I remember like when they're training that stable diffusion one, I think they said they had like 4,000 A100s or A1000s, whatever, on AWS. So you can kind of build your own supercomputer just by renting a bunch.
Yeah, I heard some horror stories about accidentally leaving that on kind of thing.
Oh god, just go bankrupt in an hour.
Oof.
When I went to CPPCon, I was walking in a group with Bryce Lelbach, who used to work at not Los Alamos, Oak Ridge National Labs, I think. Regardless, they had built a new building. Like, sorry, they don't tell us where these are, but like Oak Ridge, Los Alamos, a lot of the big national labs are where these big ass computers are. I'm trying to open up the thing now because I can't. Anyways, Where's the list? Oak Ridge, yeah, Oak Ridge National Lab. So they actually incorporate these computers or these supercomputers into the heating system of the building. So in the winter, when they need to heat the building, they use the heat from the supercomputer.
Well, it's like half the
Wait, really?
half the power consumption from these supercomputers is literally cooling. I mean, it's
And
non-trivial overhead.
yeah, but let's see, does it say us the power? Oh, it doesn't. That'd be cool though. The joke was that while they were still setting up the supercomputer, they hadn't really got it fully operational, so they weren't running, actual compute workloads on them for research. But it was getting kind of cold in the building, so they'd start up a job to do some, calculation that it doesn't yield any useful results, but does yield a useful heating into the building.
Crypto mining?
Yeah.
I don't know about that, but
Friend of mine heated his room when he was living in dorms by crypto mining.
dorms where you just have free power, that's the ticket.
No, it's no worse than an electric heater.
Yeah. But I mean, like, if you're living in a college dorm, you often are paying a flat rate, but the
Yeah, he wasn't.
electricity isn't being charged for you individually.
That was exactly it. He wasn't paying utilities.
So crypto mining is basically you use it as much as you can, because unless unless you start using so much power that this university has to investigate your room,
Lol.
Or unless it gets so hot in the room, you have to put the air conditioner on.
In the winter.
No, God.
Yeah. JB, you were gonna share your screen, or?
Yeah.
I can show you. Okay, I'm gonna have to disconnect your internet really quick. Yeah, so it's got a voxel
Ooh.
block here. It just initializes with an XOR. I've got a couple of like basic models and stuff because not everything is implemented, but like quite a few things are at this point. I have a list I'm keeping and making progress. But anyway, so one of the cool things I got done today was the fake global illumination on it. It's if I like set the light to a low level and do this on it, I can yeah. So all right. So this is kind of an interesting approximation for global illumination. It's like okay, it's kind of difficult to explain. This is what the guy said. This is kind of what I worked from. Totally fake the GI. It just casts 9 rays upwards. And okay, if it escapes from the block without hitting anything above some alpha threshold, it gets light from the sky. Otherwise, it gets a fraction of the light from whatever thing it hits.
Oh. So you're kind of propagating the light through the volume.
But one of the key things is it's got a sequential dependence. It's going to start from whatever you consider the top and work down.
Are you storing the computation in the voxel grid?
Right. All the
In a voxel grid?
all the light is in the voxels. Yeah. So here I'll show you really quick. So there's a color buffer, then there's a scale factor that's held in
Holy shit.
That looks cool.
Oh, it's nice.
So, so which direction is the light coming from that you?
Okay, so this is treating the positive x direction. That's, you can see it on the, I'm calling it the trident because I saw somebody call it the trident. I don't know.
Oh, okay.
So you can see this
That's
is coming
cool.
from the positive x direction.
Oh yeah, so you can see it's a lot brighter on that. Oh wow,
So if I
that works quite well.
do it from the negative x direction and do like an orange, and you can kind of see it like,
Yeah.
yeah. So yeah, I don't know. It's really coming along. And there's a lot of like architectural stuff I'm doing too to try and Windows build is a priority on this one. I want to try and yeah, release this as like a shareware kind of thing. But yeah, then there's like a ambient occlusion that looks at the alpha channel of the neighbors and kind of darkens based on if you've got a lot of stuff around it. If the sum of the alpha in the local neighborhood is high, it darkens it. But yeah, so it's like, so yeah, like from the different directions. Like if I come from above on the positive y-axis with green, then you know it's kind of like it's being lit from above. Here, so yeah. Yeah, so it's got some stuff going on. Yeah, it's yeah, and like I say, if this is the color data that's in the block, so this is essentially flat shading. This is with no lighting.
So when you do it, so you say you start from the outside, like in the direction the light's coming from, and then you just kind of like scan through the volume from that along that axis.
Right. So it's like this. Yeah, literally just from 0 to the dimension on the. So this is actually backwards. I had to invert it in the shader, but anyway, the idea is like I send in this index to the as a uniform integer, and then I do like a two-dimensional dispatch, and then wait for the synchronization there. So it's
The dispatch is within that slice, or
right. So it kind of called x and y here, but I do some remapping. This is the actual shader that runs. So it's like it constructs a set of basis vectors for the light. So for plus x, the that means that this z direction, we'll just call it z, is positive 1 on the x-axis. For minus x, it's minus 1 on the x-axis. Yeah, and then same for y. Here, positive and negative, and then same on the z, positive and negative. And so then the other two are just yeah, 1 on each of the other two. So it doesn't really matter. But basically this is the code to do it. So I take yeah, compute a start direction that's just the compute GL global invocation ID x and y. Just take that and yeah, so that times the x basis, that times the y basis. And then yeah, so this is yeah, I don't exactly like how that one's working, but it's fine. It works. So the yeah, so and load the previous value of the light, and that's the existing level, and then yeah, so if alright, so there's an alpha threshold for this, and I can kind of show you that. That's like there's not a lot of alpha variation in this model, but the idea is like there's a certain opacity threshold where things it's considered a hit, like when it hits it, like it's whether it continues through that or if that's considered like hitting something. So if the current
Right. So it just goes in the direction that you set, depending on the axis. What if you want to do diagonal?
It's cool. I like how simple it is, but it has a really nice look.
Yeah, like the new GI is very cool. You guys want to see my Minecraft shader?
Yeah.
Alright, I'll share screen. Right.
Seeing into the abyss. I mean, le ultimate RTA.
Yeah, I didn't choose the name.
Ooh. That's quite nice.
Yeah, thank you.
It looks so damn good.
I'm really proud of my clouds, though. Like,
oh yeah, those are really nice.
Yeah, those are crazy.
Yeah, there's also let's hope that like because I'm doing path tracing, there should be some really nice indoor lighting as well. Yeah, the speculators are kind of messed up.
Oh wow.
Yeah, I don't know if you can tell, like there's a shadow here.
So what exactly are you given like as inputs to this?
There's all the G buffers, which take care of drawing the blocks, the water, the entities, and etc. etc. There's also the composite shaders, and the composite shaders are like your overlay shader, like post processing.
Okay.
I have access to all the block IDs, like whenever it's drawing the blocks, I can store that ID.
Okay.
Okay, yeah, you can see like there's some issues here.
What are those
But-
issues? Do you know, like, what's causing those?
Yeah, definitely the reproduction. Plus, I'm doing like directed rays, where essentially in another buffer that's very small, like 0.125% of the normal buffer, and I store the light positions, right? So I do the normal hemispherical sampling, and if I hit a light source, I store it. So then when I actually do the path tracing, I shoot a ray towards the light source. Yeah, sorry, I'm not explaining it that well, but
Does that mean? Oh yes, it's only the lights that are on screen then that.
yeah, that's an issue.
Interesting.
Because it takes a while for the buffer to accumulate, and whenever I move or change my camera rotation, the buffer gets reset.
Mhm.
What happens if the light source move? Will it just mess everything up?
Sorry?
What happens if a light source move while you are not moving?
Okay, I'll show you. Basically, it does not update at all.
Interesting.
Yeah, I can make it update, but that'll mean that I'll no longer have infinite samples.
Mm.
If that
Yeah.
makes sense. But
Is it using the hardware ray tracing feature?
no,
Okay.
no, not really.
Yep.
Yeah, like my code is really fucking ugly. I think it was this.
Is the file extension fragment shader header? Vertex shader header?
The final is just the final overlay shader. Like, it's the same as the composite ones.
No. I'm saying the file extension, not
Oh.
the actual shader code. That's what I'm looking at, of course. Some weird. I just haven't seen FSH as a file extension for shaders. So.
Now, if I remove the light, it should slowly update. Yeah, I mean, it's really
Slowly.
Interesting.
But yeah, that's about it, really.
This is unrelated, but do you code with no syntax highlighting or linter for GLSL?
I tried installing GLSL plugin for Visual Studio, but it does not recognize FSH files for some reason. I kind of got used to it, but there is highlighting in GLSL files.
Oh, okay. Yeah, there's some of the extensions you can add file extensions.
Actually, I think if you go back to one of those FSH files, I think you can just click in the bottom right corner of the screen where it says plain text. You can just click on that and make it GLSL.
Oh, nice.
Yeah, you can configure the file association plus that too.
Okay. Wow. I did not know that.
I guess I asked about the file extension because I'd never heard of FSH or VSH for shaders.
Yeah, that's just.
Yeah, I don't really care what it is. I hadn't heard of that, so I was new to me. I mean, I guess the compiler cares what it is, but.
Well, I think Optifine requires you have FSH files.
Neat.
But Optifine is also really fucking limited because you can only use 15 buffers. And that's kind of not enough if you want to do a lot of stuff like separate buffer for water, clouds, denoising, etc., etc. Yeah, but the Minecraft shader community have figured out a way to pack a vec3 into a single float. Oh shit.
Just really limit the number of bits per channel, I guess.
Ooh.
Yeah, I can actually increase the... My code is like a huge mess right now, but...
It looks so much better than some of the RTX stuff that we tried on my last server.
Huh.
Eh.
Why is this not better? Probably because of the distance. Yeah, it's not perfect, but...
The very bright sun.
True.
Or is it just the fog from the view distance being short?
I use face function, the henny greeny one, to do the fog. So closer to the sun is brighter, essentially.
And
But yeah. I don't know. I am kind of proud of my clouds. I think they look
as you
nice.
should be.
I kind of annoyed JB with spamming with the clouds, but oh well.
Can you fly up into the clouds?
Nope, but I can do that as well.
Bring them down to us.
Hmm.
Are they like really high or something?
Yep.
Oh, what's that thing you were doing with the noise from the fog? You had that handy?
The what?
Where you had the noise pattern when you sampled through the fog?
Yeah, I just sampled from a 3D texture.
Yeah, that looked really cool. Or is that already doing that?
I just have a density that I multiply, like, I calculate the volumetric lights, and I also just multiply with the density, which is just the sampling from the noise. Oh, come on. Okay.
Looking at the pop ratings, and apparently the 3090 is about 3 times faster than my current GPU.
What's your current GPU? 1090?
No, it's a
1080?
Radeon 7. It's an AMD card.
Oh. Hmm. Radeon 7. What's that year from? Is that
It's getting a little older now. I think maybe 2017, 2019, I guess. Yeah, I've had it for a bit now. Almost 4 years, I guess. Back when $700 was a very high-end GPU.
Yeah. Wasn't 800 like kind of the top for a while?
The
Yeah.
like a great, but that's like nobody bought those. So,
Yeah.
They really weren't any faster in games, is the thing. Because yeah.
Is that function called clouds 2222?
Yeah. I'm not the best at naming conventions.
we've been working on coding conventions.
I also see some rather large constants
Oh yeah. There's a lot of
commented
nines
out.
there.
Yeah.
Indentation needs work.
I don't, but I'm kind of lazy right now. Yeah, I'm planning on doing TAA and maybe some sort of upscaling, temporal upscaling as well.
Is the Tech Power Up website a good website for relative performance of GPUs?
I don't know.
No clue.
I was just looking at numbers, just raw numbers. So I suppose there isn't. Maybe it's the hell's the one that there's a good comparison site. Maybe it's that one.
Well, it's saying the 3090 is 212% better than the Radeon 7.
Yeah,
However, I can't find my GPU, which annoys me.
That's right about 3 times, yeah. Like it's like 13.9 versus 36 kind of territory. The cool thing about the Radeon 7 is the memory bandwidth. Like the NVIDIA cards are just kind of catching up with that now. Like this thing had a stupid wide bus, and so it had like a terabyte of memory bandwidth per second.
Dang.
Okay, JB, you meant this, right?
I think, yeah.
It looks pretty yellow.
I think it's maybe
Like the noise and the...
No, I think it's pretty blue.
Hold up.
Wait, what?
Oh, wow, that looks really cool.
Yeah.
I
It's
like
okay,
where
I
the
guess.
trees like block it.
Yeah, I'm doing a multi-scattering approximation from this one research paper I found.
Hmm.
it's the Oz one. Is the multiple octet.
Yeah, exactly.
Wow.
Oof.